So welcome to the New York Information Security Meetup slash Cyber Guild. I appreciate you taking the time to chat with today. You and I have some history, and we worked in the past, and it's always fascinating to see founders that are building something, right? And you're a PhD. Again, I've had several PhDs that are founders in recent years. And it's always fascinates me because you had a great corporate job. You were successful, working for someone else. So if you don't mind, let's kind of like dive right into, why you decided to, move the light side and move to the dark side and create your own business.
Yeah. Well, I actually, I like working for myself. And there's pros and cons to that, but at the end of the day, I feel like I've accomplished something, right? And I have things that are under my control. My frustration of working with a large company is really the slowness at which it can move and the sort of lack of transparency to understand how the whole thing is working, right? And my background, as you mentioned, is I have a PhD from UC Berkeley. And I did research, and research is a small team, right? It's not a giant corporation that's doing research on physics or anything like that. It's small team, you collaborate, you iterate really quickly. And I like that. I like to work in that way. And so for me, it's a very natural fit to go to a startup. The one time, when I left academia, I started an ad tech startup. But the one time after that, I did work in a big company, which was at Merrill Lynch. It was like an internal startup. And because at my job, there was 8 other people, and my job, along with those 8 other people, was to build a high frequency trading business within a very manual trading business, which involved about 2,000 people, right? And so even though I was working in an organization that had 100,000 plus employees, we were treated as a startup internally. We had funding like a startup, and our job was to break things and move quickly. And we did that. We built a huge business in 3 years, $1 billion business. And that was exciting. That was, and so that's what I enjoy. I like building new things. I like disrupting old ways of doing things. And that's, what we're trying to do now.
So, in terms of trading, right? I mean, there's some skill sets there that you took away from that particular area, and took that knowledge and was able to apply that, to Wallaroo Labs, right? Some of that internal knowledge, the ability to scale and process some data, right? Is that a correct assumption?
Yeah. I think there's 2 ways to look at it. One is, the trading business that we built at Merrill Lynch is a data business, right? It's automated trading, meaning, we used to call them trading strategies. Nowadays, you call them models, machine learning models. But it was machine learning models that you develop, and then you run on millions of data points every second. And we had 25 data scientists or quants that developed these models, but we had 625 other people. And on top of those 625 other people that were doing productionization, that were deploying, that were supporting, that were operating, we spent $100 million a year on infrastructure, right? And so the biggest takeaway was that experience in that you can relatively quickly develop some very powerful models to extract value from the data, but getting that into production and getting it live against data at scale is a hard, expensive business. So when we started Wallaroo Labs, our mission was to simplify that, right? Our mission was, you have a model, you have an algorithm, you have some analytics idea. We wanted to kind of take that experience and some of the technological tricks to really get you up and running very quickly, and to let you run at large scale and at very low cost, right? And that was born out of that, trial by fire in the trading business.
So what's the just out of curiosity, what's the origin of the name? It's unusual. What is a Wallaroo?
Wallaroo is actually, it's like a kangaroo. It's one of those Australian animals. It's like a small kangaroo, and the origin of the name is we're a tech-heavy company, and our developers, it's pretty flat. And so when we were coming out with how do we name the product, we actually had a competition. And I was like, okay, fine. And so our developers, I don't know who came up with the Wallaroo as the initial idea, but we had a vote. And Wallaroo won by a landslide. And as a small company, it's a bit weird to have the product and the company completely different names. So we just said, okay, if our developers like cute cuddly animals, and so we sell solutions that make the life of data scientists and data engineers a lot easier, right? So it seemed like if that resonated internally, it would resonate as a name, to those folks externally.
Yeah, absolutely. And if it's a cute, cuddly and logo and animal, I mean, people would probably remember that. It's and I initially, again, I assume it was a small kangaroo just because of the similarities in the names. So people are comparing data to oil, basically saying data is a new oil, right? So how do you and the I don't know if you can touch upon the problem of aggregating big data and making sense of it, and maybe there's a lot of floating terms around like data lakes, data ponds, data. I mean, there's all kinds of jargon out there that people use frequently, and then maybe you can jump in, more specifically, potentially how are you solving some of the areas within cybersecurity, using your technology, and where does it fit?
Yeah. So you're right. There's so much jargon. It's kind of hard to keep track. There are so many new companies. It's hard to keep track. But fundamentally, where we fit in is three trends. And one is around the movement away from batch processing to what's now known as stream processing, right? And the reason that's important is because there's a lot of value in the data. Right.
Vid, if you don't mind,
Yeah.
just for the sake of the folks that are not familiar with, kind of the difference between batch and what batch means.
Yeah.
It'd be great if you can describe that.
Yeah. So let's do 101. So batch processing is, what everybody usually is very familiar with, which is data is generated, right? It might be generated from your mobile phone. It might be generated from you looking at the web. All the events that you're doing on the web, that's all data. It might be generated from your credit card transactions, right? That data is generated in real time as life happens. But then normally what happens is that data gets all dumped somewhere, right? It's not analyzed straight away. It's dumped somewhere in some kind of data store or database or something. And then at the end of the night, all those transactions, all those events, or at the end of the week or the end of the month, are analyzed in one go, in one batch, right? So you're not analyzing the data, you're not acting on the data as soon as it's generated, you're batching it up, and you're doing it in a batch. And that batch could be at the end of the day, it could be in an hour, it could be in a week, it could be in a month. That's batch processing, right?
Stream processing. And Vid, quick question. So why has that traditionally been the way? And maybe with some of the drawbacks for that.
Well, there's a lot of different reasons, but it's just first of all, there was no expectation that you had to do something straight away. There was no people and systems didn't operate at that speed, so you didn't need it. There was no requirement. That was number one. Number two, a lot of in enterprises you had very monolithic databases that stuff went into, and it was hard to get stuff out very quickly and operate on it very quickly. So it was just very expensive and complicated to do anything other than like, let me write a query, let me, on some database, let me get 1 million records and let me run some analysis on those 1 million records, right? And so there are a variety of reasons that existed, but I think the reason why that's changing to what as I mentioned is now called sort of stream processing. Stream processing is you're treating those events and you're acting on those events and you're understanding those events as they happen,
Mm-hmm.
right? So there's a transaction, you buy a credit card, you're looking at that transaction not at the end of the day, not at the end of the month. You're looking at it right then. You're trying to figure out if it's fraud. You're trying to figure out what else I should recommend the customer. If they bought blue jeans, am I going to recommend to them? Because and so stream processing is being driven by two reasons. One is that there's a lot of value in that data straight away, right?
Mm-hmm.
Like if you're looking to buy blue jeans, and I want to recommend to you something that goes with those blue jeans, it's far less value for me to recommend them to you at the end of the month because you probably already bought whatever you were going to buy, right? Whereas you're shopping, you're on Banana Republic or whatever, if I can recommend something based on what you're putting in your shopping cart, there's some chance that you might actually buy it, right? Because you're in that mindset right now. Same with trading, like financial trading, right? Same with in security. If there's an intrusion, there's a value in knowing that straight away, right?
Yeah, there's also the terms IOCs, right? Indication of compromise, for example. If it's old,
Yeah,
right? If it's more than a day or more than a few hours, then it has a very different impact than it is if something happens just immediately in the past several minutes.
Yeah. So one reason is that there's a lot of value in that data that you need to get to quickly. The second reason that there's a transformation going on from batch to streaming is that there's more and more data. And the problem with batch processing is, it's okay. You have, you started with megabytes of data, then you went to terabytes of data every day. Now you're in the train of petabytes of data a day, right? The problem with trying to do petabytes of data processing in a batch way is, first of all, it's a shitload of data. How can you keep up, right? And two,
and that's a scientific term, right? Shitload.
Yeah, that's the physics term. My first class, that's what they taught us. But there's a load of data, and the other problem is storage, the cost of storage, right?
Mm-hmm.
So it becomes increasingly difficult. And what's gone on, especially in security areas and in IoT in particular, is you are seeing use cases where the amount of data generated in a day is like 100 times more than even that we had a few years ago, right? The data coming from connected cars, the data coming from manufacturing facilities, the data coming from, we just signed a contract with the US military for a security project involving IoT devices. The data coming from million IoT devices far exceeds the amount of data that we've ever been used to, and right. And so what is typically happening where people don't know how to deal with that data straight away is that they store it somewhere, and then at some point they flush it because they can't afford to save it, unless there's regulatory reasons where you have to keep it. In some cases, you have to keep it around for a while, but it's not getting monetized. It's not getting used. The batch thing just becomes like, it's like the hoarding, right? It's like you're buying, you're getting toilet paper delivered every day, and you can't keep up, and you're just putting it in the closet. And so that was another physics lesson, by the way. And so you have to be, if you're going to actually do anything with the data, you have to look at that data straight away, not just stick it somewhere and forget about it.
And a quick question, just out of curiosity. So you're talking about these IoT devices and, connected cars and so on. Why are these connected devices generating so much data? If knowing that most organizations can't even keep up with it or process it. So it's like, what's the point of a device spitting out this, and again, scientific term, spitting out this information without anybody on the receiving end?
Well, I think the data aspect of it was an afterthought. Like, what do we do with the data?
Mm-hmm.
Afterthought. I mean, it's very typical. You're seeing now in a lot of places, we're talking to customers where they've got data, and then they invest in the data science, and they've got little research projects, but they haven't figured out how to put it into production, right? It's the same. It's in some ways, people have, either for regulatory reasons or for other reasons, have put sensors everywhere, right? Mm-hmm. And so in the automotive industry, there are hundreds of sensors. There's 5,000 data points that are continuously generated in a modern connected car, and the car itself generates several terabytes of data.
In
Right.
what time? In what time frame?
In one day.
Wow.
One car.
Wow.
Right? Because everything. A car is its entire ecosystem. There are all these different, basically computing units on the car. There's actually a networking bus. Modern cars are very complicated things, right? You have tire pressure. You have the common things, but you have all sorts of other crazy things, right? And so there's a lot of data, and the thought of like, okay, now there's all this data. What the hell do we do with it? Has been left for the most part to an afterthought, right? People read these McKinsey reports where they say that all this data will generate $750 billion in value, right? And so but nobody's really thought through, well, how do we actually generate that value, right? So they're sinking a lot of costs. They're sinking a lot of infrastructure investment into all this IoT stuff, but they've left the other part of it is like, how do we actually monetize that data, or how do we use that data to secure something? It has been coming second. At least that's our experience in talking to folks.
So your goal is to really assist these organizations to mine for value, out of that ocean of data points that they collect
as fast as possible and as low cost as possible.
Right. So what are the issues, aside from obviously the scale, which is one of the issues, right, to capture it and scale? What other issues are, these organizations are facing? Obviously, they gather, they got data scientists, right, assuming they have the infrastructure in place. They define the issue, or define the problem they want to solve, right? What else now they're facing, facing what? What do you think that the steps are for them to actually mine for value? And I'm assuming again that they, once they know the problem they want to solve, the definition of the problem, like how do they get in, kind of face that and go ahead and trying to create a project around that? What's the process looks like for most of these organizations?
Yeah, it's a little haphazard. So I think, it depends on the maturity of the organization. It depends on how long they've been dealing with the data. So if you look at a large enterprise that has historically been data-driven, like a bank, right? You've had different groups within the banks. You've got the security group, you've got the credit card group, you've got the trading group, you've got the risk management group, right? And so what has happened, what we're seeing is that these individual groups have done their independent thing, right? And they're technically quite advanced, and they've started playing with data science and doing some data science stuff. But where I think they need help is the fact that they've got disparate data. The data isn't normalized into a standard way, and they're using different tools and different technologies to get their analysis and science models launched, right?
So Vid, if you don't mind, just again, 101, what do you mean by data normalization? Like what does that look like? And why is that even a problem?
Well, because a lot of the modern applications, you have, so let's take a very simple example. Like, let's say you want to do a model around credit card fraud, right? That seems relatively straightforward, right? Mm-hmm. But the reason you have all sorts of data problems, forget even the model or the runtime, the reason you have all sorts of data problems is, first of all, you have a transaction, great, but probably a really good model doesn't just look at all the transactions. They look at the customer's history and their profile and the customer segment. So now you need to have a database which holds a bunch of consolidated customer information. And as you know, within these large enterprises, there are typically many different data stores with customer information in many different formats. So you immediately have to solve the problem of, first of all, bringing all that data together and creating some kind of unified view of the customer, right? If you're going to use that information. Another thing that you might do is it's not just a matter of putting these models into production, but you have to actually validate these things, and you have to be able to audit them. You have to be able to reproduce it. You have to be able to, typically these organizations might have some kind of model risk governance group, right? So let's say, and again, I'm just going to say something simple, credit card. And the reason I use credit card is because if you're in security, you can understand it. If you're in consumer marketing, you can understand it. It's an example everybody understands. So let's say you have to be able to explain later on whether this model is working and whether that transaction which was denied was correctly denied, right? So you need to know if that transaction was denied a month ago, you need to know all the information that went into that scoring as of a month ago, right? And so if you don't have that, then you have to go to all the different source systems again and reconstruct that data, right? This was a transaction. This was what the model saw. This is what this prediction was. This is what the customer profile was from a month ago. And so you have fundamentally, before you can actually do anything with the data, you have to solve these problems around data fragmentation and sitting in different data sources and being structured in different ways. Like you have to solve that, right? Mm-hmm. To make any progress. But then the second problem, let's say you solve that, and let's say you have good data to work with. The problem that we're attacking is once you have a model, bringing that model to live data, right, is a very hard thing if you're a large bank or you're Akamai or you're a whole host of companies, right? And the simplest way to understand that maybe is Twitter as an example, right? One of the core applications of Twitter is the trends, right? Right. So if I give any developer, like, here's 1 million tweets, they can easily write some code. They can write that code. I could write that code in an hour or 2 hours. They can easily write that code that tells you that the top 5 trending tweets are Trump and Black Lives Matter and etc. Right. But then I say, okay, can you take that and can you bring it to the live data, the millions of tweets a second, in a way that it works, it doesn't fall down, it scales, it's resilient? That isn't an hour of work, right? If I told you that's an hour of work, you'd laugh me out of the room, right? It's not even a week of work, right? If I told you it was a month of work, you might be like, well, I'm not sure if it's a month of work, but let me see if you can actually do it, right? And Twitter took years to build that infrastructure, right? So there's a lot of problems around building automated systems, about running machine learning algorithms around automating things like security or fraud. There's a lot of different problems that you have to solve, and so we're not trying to solve all of them, but I think we're hoping to help you solve at least a big chunk of them.
Right. So you solve you solve the issue of the disjointed data sources, right? That's number one. So you're allowed to suck in the data from all different sources in real time, right?
Yeah.
And then you have the ability to run analysis on that data in real time, despite the fact that these data sources might be, not normalized, right? They're disjointed.
Right.
And then do you provide also help with the algorithms, or is it something that the customer typically does on their own?
Typically, as a customer, the customer has data scientists, or they have analytics developers, and we typically work with them, to deploy them at scale into our platform.
So whatever you can divulge, what is the secret sauce, right? Obviously, how do you take that massive amount of data and be able to process that in real time without the system just going, belly up? Again, another scientific term.
Yeah. So we wanted to, when we build this thing, we wanted to achieve 2 different things, right? One was, on the one hand, simplicity and power, right? And on the other hand, it was performance and scalability, right? And the two are often at odds, right? And that's where the secret sauce comes in. So when I mean simplicity and power, think of what, I don't know if there's any developers on this, but think of what's going on in the development side of things. Like Python is just exploding, right? It's a simple language that doesn't require you to know distributed computing. It allows you to write relatively simple code. There's fewer and fewer developers that are working in Java or C++, and there's more and more Python is just exploding, right? And the reason, partly why Python is exploding, is because of the powerful toolkits and frameworks, right? TensorFlow, things like that. That Google or Facebook or in the community, they're very, very powerful, and they allow you to do very powerful things with a few lines of Python code where you have some data. And so there's a lot of power there. There's a lot of simplicity. On the other hand, it's not very performant. Python is not very performant. It doesn't scale. It's building a distributed system that's resilient, which is what you want in production, right? When you're going to throw a shitload of data at it, again, I use the physics term, that's really hard. So what we wanted to do is we wanted to let people use the simple languages, use simple ways of writing code, but use the toolkits that are familiar with, and then on the back end, get this very scalable, very fast system, right? So the idea really is that you write in Python, you don't have to worry about all this distributed stuff. You use your TensorFlow or use your standard analytic stuff, and then it's going to run in this distributed environment, which has the performance of C, right? So now it's running across multiple CPUs on multiple machines, is giving the performance of C. And so that thing that works on your laptop with 1 million records, right, will all of a sudden run over here now without changing your code. It will run on 1 trillion records, and it will do it really fast and really cheap, right? That's our vision. That's what we've been building.
And now, when you say cheap, why is that a concern? This is the first time you're bringing it up, like in terms of the cost associated with running, some of these algorithms.
Okay, so the cost of processing an event has to fall by 10x from where it is right now. And the reason it has to fall by 10x from where it is right now is because if you look at IoT and other things and you project out 3 or 4 years, there's like 20 zettabytes. And I don't even remember what zettabyte is, like 10 to the 20 or something like that.
Vid, it almost sounds made up. It's so crazy.
Look it up. It's actually, a zettabyte actually exists. It's like way more data than we're used to dealing with, right? And if you apply today's cost structure to it, nobody's going to do it. It's going to be so maybe a simple way of thinking about it is if I told you, if you're spending $5 million a year processing data, and I told you in 4 years you're going to have 10 times more data, then you're like, okay, I guess I'll be spending $50 million. And actually, it might be $100 million because my algorithms are getting more complicated.
And so these numbers you encounter? I mean, it sounds like a lot to me. Like, I mean, I'm assuming at enterprise, at large scale, those are kind of the numbers that companies spend, right?
What's going to happen is you're going to de-scope your project. You're going to be like, I can't afford to do that. So I'm just going to throw away most of this data. That's what's going on. Did airlines generate an airline like a standard, American Airlines or whatever, generate from their flights 40 petabytes of data a day. Mm-hmm. What percentage of that data they use? Like 2%.
Wow.
Okay. So what's going to happen is if you can't reduce the cost and you can't increase the speed, people are just going to throw away their data, or they're going to stick it somewhere and forget about it, and then at some point wipe it clean, right? Mm-hmm, mm-hmm. So in order to actually do all these crazy things, when you read the McKinsey report where even before we have cancer, somehow the thing the drone comes and flies us off to the hospital or whatever, you need to be able to process data much faster and much better scale with much lower cost. So otherwise, none of this stuff's going to happen. None of that crazy stuff that you read about is going to happen, because people can't deal with the data. It's too complicated. It's too costly. It takes too long. It's gonna be like what the airlines are doing. It's just gonna sit there.
Mm-hmm. And in the cybersecurity space, you mentioned IoT. Where do you think that the applications are? Right now, the next 12 to 18 months, where you think that Wallaroo Labs is an applicable solution. Is that in the endpoint security firewall space? I mean, we all know that these everything spits out a lot of data points. I think every laptop, every IoT.
Our conversations are across the board. We have with if you think about the Defense Department, the military, it's an edge environment with a lot of IT on the edge, and you're going to have to do a lot of processing at the edge, right? Not just in a centralized cloud. If you think about a lot of with the move to cloud, there's a lot of cloud related stuff with the move to cloud. So if and anybody that's got big infrastructure in the cloud, we're talking to one large bank that generates their cloud infrastructure generates 1 million messages a second, and they can't analyze that in real time. They haven't figured out how to analyze in real time, right? So there's a lot of this new infrastructure, whether it's IoT or cloud or whatever, is generating huge amounts of data that people are trying to figure out how to analyze faster and in real time. So we're seeing, one company that we're talking to that claims to be the world's largest security company generates 15 petabytes of data a day from tens of millions of messages, right? Which is
do they actually collect it and they keep it, or they just process it and then let it go?
Well, they're extracting, I don't want to speak for them, but they're extracting some value out of it, but there's a lot more value. And in particular, it's complicated because some of that data, there are a lot of, if you could figure out how to analyze that data in different ways, you could do a lot of things with it, right? So, it's all over the place. We're talking to a DNS provider around actually optimizing DNS latency, because if you can figure out in a very localized fashion what the latencies are, then you can use that to route stuff, more efficiently. So that's not exactly a security thing, but it's not just all security. That same infrastructure, the same infrastructure has a lot of different applications, not just security, but traffic routing, SLA, right? And it's the same data, right? So the interesting thing is, again, you have the same data that can support a variety of very valuable applications, and it doesn't make sense necessarily to attack these as completely separate groups doing completely separate things, right? Because you're replicating a lot of the work.
Mm-hmm. It sounds to me that there's almost a place for someone to take ownership and say, okay, let's tackle a specific cybersecurity problem, whether it's endpoint, firewall, or whatnot. Take your engine, your Wallaroo Labs, and then build a product or a service around it. Basically, just take that, because it's you're providing that tool to tackle that problem, but someone out there needs to, package it, right? Needs to write the algorithms, solve that problem, and then go to market with it. Call it something else, but powered by Wallaroo Labs. Because you're dealing now with some very large banks and very large companies, but there might be a place where even smaller organization or mid-sized businesses do not have the capacity to write or tackle this problem on their own. Someone might be able to be there and fill that gap using your technology.
Yeah, we're very open to working with partners. We can't do everything. We're a small company, so if people and we're talking to folks that have already existing clients in certain verticals, like trains, right? Or whatever. And so, I think that's a good way for us to scale our business as opposed to like trying to do everything ourselves.
Yeah. So kind of lead me to the next question. What's the, you've been doing this since 2014, right? That's the inception of Wallaroo Labs. Like, I mean, that's where you started the company, or was it earlier?
Yeah,
2000,
2017 actually.
sorry, 2017. So
Yeah, yeah.
it's been 3 long years or short
Yeah.
years. Um, and
Oh,
where do you see where do you see the company, like, 2 or 3 more years? You mentioned the problem is really exponentially growing, and so where do you see the company? Are you planning to expand? Yeah,
yeah, yeah.
or
No, actually, we're hiring. We're
Mhm.
hiring business development people. We're hiring technologists. And what we're seeing is, in the last 2 years, this technology is not like two guys in the garage building this thing or two gals in the garage. It's taken 2 years to build something that has what the claims that we make. But the other thing that's happened in the last 2 years is that the amount of data has exploded, and the desire for people to act on that data in real time has changed. Batch, doing it at the end of the day, doing it at the end of the week used to be good enough, but it's no longer good enough for a lot of people, and they're starting to try and figure out what to do. And the other thing that's really happened in the last 2 years is that AI has really exploded. Whereas 2 years ago, you wouldn't see data scientists in many of these organizations. Now they all have some level of exploratory or sort of mid-level maturity of data science, right? And now the problem is, like, now what do I do? And can you guys help me? So I think there are a lot of different trends that are converging: the AI, the data science, the move from batch to real time, and the explosion of data. And so we're actually, I think, very well situated with those trends which are converging to help other companies deliver value from their data. We're gonna basically, our simple task is to let our customers focus on what they're good at, and we take care of the plumbing. That's it. We're plumbers fundamentally. And so if your business is DNS, if your business is this or that, we want you to focus on that. We want you to monetize the data that you have. We want you to be the best in that category and optimize your resources. And we're going to help you on the sort of computing side of things. We're the computing infrastructure.
Interesting. So yeah, and I agree. I think even that trend of companies focusing on the core competencies is being established now. I think companies realize that they should focus on strictly of what they do and what generates money for them, and then let somebody else deal with the rest of it. So just kind of like parting words. Things have really changed. In the past several months. How did it affect your company, your business? The way you do, you interact and do business now. Do you see any changes in the way people interact, and maybe some positive changes in your life in particular?
Well, I think. Well, I don't know if I would. I don't think there's any positive changes in my life. I mean,
Well, some people say I've interviewed folks that are saying that they learn how to cook or establish new hobbies. So it's like it really depends.
yeah. Unfortunately, I just end up working more. I guess I should learn from some of these other folks. I think when COVID happened, we decided to take a step back and kind of reevaluate the marketplace and the opportunity. And so there's a few things that we're doing. We focus. We used to be a bit more horizontal, and so we're focusing now on just a couple of verticals: financial services, IoT, and security.
Mm-hmm.
So that we kind of said, okay, who's most likely to have the problems that we can solve, and who's most likely to actually invest given what's going on, right? And then secondly, I think what's happened, is that AI, we're leaning into AI, right? Because AI gives. We just had a call today with a company that develops a bunch of security and and other risk applications for their customers. And they have all this data. They have huge amounts of data that they are gathering from different customers that they service. And they are limited. This company that's providing these solutions is limited by.
Somebody muted you, Vid. I don't know who. You can. I can't unmute you. You need to unmute yourself.
Okay.
Oh, here we go.
All right,
guys, do not play with the controls.
I didn't know I was that boring, but anyway. But and so they have all this data. They have all this customer data. The customers are saying, we want to do this with the data. We want to do this with the data. We want to do this. And so what's interesting that we're seeing, and this is something we're now seeing 2 or 3 times just in the last few weeks, is that there are a lot of companies that are aggregating different sources of data, whether it's from their customers or whether it's from internal organizations, right? They're creating data lakes, right? And this is actually even true within the Air Force or within the military. And what they're trying to do is they're trying to figure out how to give their customers, their end users, more access to the data and better ability to actually run analytics on it or run a model on it, right? And so this idea of, I think the other trend that I think is going to be big is kind of self-service machine learning, right? There's all this data, and there's only so much that these 3 data scientists can do with the data, or these 2 analytics developers, or that you internally within one group can figure out what to do with the great data. So if you can open up access to the data and give people tools to analyze that data, that's great internally for an enterprise organization, and that's great for organizations that are providing security solutions or providing fraud solutions to their customers, because then the customers don't have to deal with the infrastructure, they don't have to deal with the scale issues. They can hire a data scientist, one data scientist they can hire, that's relatively cheap. And that data scientist goes in and can create tons of value on the customer's own data, right? And so the other trend that I think is going to be big is this idea of self-service, right? That somebody takes care of the infrastructure, somebody takes care of the scale, somebody takes care of bringing all this data together, and then you as an end user are given the tools to monetize it. And we're seeing people talk about this. So that's something relatively new. And I think it's driven by COVID a bit, because the cost of doing this over and over again, the same data, doing different things within different groups, you need to figure out how to monetize that data faster, and you have to figure out how to do it much lower cost. And so this idea of, like, I think different companies are trying to think about, how do I do this? How do I achieve that, right? And so that's something I think that COVID is actually accelerating.
Yeah, interesting. It's the whole space is super interesting, and I think there's going to be more and more applications as companies and organizations realize that they can do it. I think there's a lot of organizations now that they just assume the problem is too big, right? So because traditionally it was.
Yeah.
So I think the more organizations discover it, and and I think that self-service makes total sense.
Yeah.
That will allow for people to come and basically without knowing, it's going to be almost like a black box solution where they just go in and maybe ask query using NLP, query the data, and the machine would just spit out the answer without really knowing what's the underlying plumbing which you probably provide.
Right. And yeah, exactly. And people gotten used to not knowing how the model works, right? I mean, who knows how the model works? Like, you spin up something, you run some TensorFlow on it, and so you don't need to know how the model works. It just gives you a result. That's a pretty good result. Great. So what we're saying is you shouldn't need to know how the infrastructure works either.
Right. Interesting. Well, Vid, it's been a real pleasure. I think I learned a lot. I hope the folks on this call learn a lot as well. This will be, obviously it was recorded. I'll provide to the rest of the group, and I really hope that potentially when everything's open up, maybe you can come over and do a live demo during our monthly session in New York City. and I'm looking forward to see where things progress, and see how many more application you can find, for Wallaroo Labs, and specific in the cyberspace, and help to tackle that problem. It's a big, most entrepreneurs say you got to tackle a real big problem, right? I think you tackle a real big data problem, right? And
Right.
either way, it's worthwhile endeavor. So I appreciate that. So thank you very much for joining. I appreciate taking the time, and again, looking forward to hopefully seeing you in New York City sometime soon.
Yeah. Well, thanks for having me. And if anybody wants to connect with me on LinkedIn, I'm Vid Jain, VID JAIN. Just find me on LinkedIn. I'm the only one. And happy to hear your thoughts or talk about your use cases. I'm always willing to, hoping to learn from other people's experiences.
Super. Thank you all for joining, and again, looking forward to seeing you all next time. Appreciate it.
Thanks. Thank you, everybody.
Take care. Bye. Thanks again.